Alright, this is lesson 41. We're going to talk about complex fractions. So complex fractions, for example, let's go back to here. This is something we need to talk about before we even start it. But can we cancel out x and x? Why not? Turn your neighbor, explain why not. Where are there parentheses? Around each numerator and denominator, okay? Shh. So no matter what, no matter how big or complex this numerator denominator is, you always need to make sure that you know that there are parentheses there. And by the way, what does this fraction bar represent? What operation? Division, okay? You got it? Alright. These are the steps. They're up there. Here we go, number 1. Okay, these are called, quiet down please. These are called complex fractions. They look really complex, but they're not. It's just, in math, when we have larger problems, then we start trying to make them compact so they look a little bit, they don't take as much room. So this is a complex fraction. It looks a lot scarier than it is, but remember what the rule was earlier, that whenever you have a numerator or a denominator, you are going to assume that there is a parenthesis. Okay? And again, what does the fraction bar represent? Division. So this is really like saying this whole numerator divided by this whole denominator. So an easier way to write it is just to write it like this. 1/4 divided by the quantity of 1/3 plus 4/9. Okay? So we have a first parenthesis divided by a second parenthesis. So we're going to do PEMDAS. So parentheses, there's nothing I could do in this parenthesis, but there's in this parenthesis I can simplify. We got 1/3 plus 4/9. So we find a common denominator of 9. Okay, and we know that it's going to be 3/9 plus 4/9. Bring the rest of the problem down, and we get 1/4 divided by 7/9, right? Because we add, right? Now all of a sudden this is simple. How do we divide fractions? We multiply by the reciprocal, right? So we're going to do 1/4 times 9/7. Can't simplify anymore. 1 times 9 is 9. 4 times 7 is 28, and we're done with number 1. Okay? Was that very hard? No, not very hard at all. Okay?
Yeah, and then number 2.
And number 2 is going to be hard.
Yeah.
So again, always making the whole numerator, whole denominator in its own parentheses, dividing, and then we're simplifying and multiplying by the reciprocal. So like number 2, we got 2 over x minus 5. This one looks a little scary. Okay, but it's really like saying this whole numerator divided by this whole denominator. So I'm going to rewrite this as 2 over x minus 5 minus 4 over x squared divided by 2x minus 10, okay? So this is just like before. We need to simplify each numerator, or each parenthesis. So this whole parenthesis is something we've done already, subtracting rational expressions. So x minus 5 and x squared. There's an x minus 5 here. Is there an x minus 5 here? No, there's not. So we're going to multiply this right side by x minus 5. I'll put that over 1. Okay? And the numerator as well. Oh man, my fat fingers. There's the answer. You can do it. Okay? This right side has x squared. This left side doesn't, so I have to multiply by that. Okay. So now we have 2x squared all over x squared times x is going to be x cubed minus 5x. Negative 4 times x is negative 4x, and negative 4 times negative 5 is positive 20. Okay, that's your first parenthesis. I just simplified that. It's a common denominator. Okay. So now I need to continue, and I'm going to multiply by the reciprocal, but as I multiply, I want to see if I can factor anything out so that I can, cancel things out. What can I cancel out of this first numerator here? Or factor out? What can I factor out? A 2. So I'm going to factor out a 2. This will be open parentheses x squared minus 2x plus 10 all over. The denominator I could factor out x squared. And then I'm going to multiply by the reciprocal, but 2x minus 10 is going to go in the denominator now. But I could factor out a 2 here also, which is going to be real nice because then I could cancel the 2's out. So 2 and 2 cancel out. So x squared minus 2x plus 10 all over x squared cubed minus 5x squared times x plus 5. Okay? So I'm going to multiply across x squared times minus 2x plus 10 all times 1 right here. It's just going to be the same thing. Okay? Then I have x cubed. X cubed times x is going to be x to the 4th. X cubed times 5x cubed is going to be 5x cubed. Should be cubed there. Let me fix this. And then we have we have it right now. Negative 5x squared times x is going to be negative 5x. Oh my goodness. Cubed. And then it's supposed to be minus 25, but I made a mistake here. There we go, that's better. Combine like terms, there you go. It's your final answer. So this is what happened up here. X cubed times x is x to the 4th. X cubed times negative 5 is going to be negative 5x cubed. And then negative 5x squared times x is negative 5x cubed again. Negative 5x cubed plus negative 5x cubed will be negative 10x cubed. Okay? And then we got negative 5x squared times negative 5 is positive 25x cubed. That's your. Okay? That one's a harder one. Today what I really want you to do is make sure you get this numerical one down. We're going to do a couple of these. Yes, sir?
Is there any eyes on the homework?
Not tonight. Because there is no homework tonight.
This deserves a dang meme. Which one up there?
A dang meme?
A dang.
A dang? Okay, so like you do today's Friday, let's have 1s till the 2's about number whatever. Consistent of 1 about the opposite. Okay? Ready, set, go. Alright, continuing on here. Number 3. Shh. Okay, let's see you do number 3. On this one, you should look like this. Right? Okay, good. Number 4 by yourself. Go. Here we go. This one, you should have. Raise your hand if you did that first step correctly. Okay, good. What's our common denominator on the right? 5u, right? So, raise your hand if you did that step correctly. Okay, good. And then our new common numerator is going to be u squared minus 25. So I'm going to multiply by the reciprocal. And therefore, you could multiply it out and you get this following answer. Did you get it right?
Got it. No. Oh, I did.
Okay, that's it. That concludes the lesson.